Friends, it's my pleasure to welcome you for this unique session, which is very topical and very timely because of the recent tunnel collapse episode in Uttarakhand, which has hogged a lot of limelight and headlines and all our attention span and concerns during that phase, followed by, of course, a superlative sense of national pride, and it has evoked a lot of sense of accomplishment and relief. Having said that, I'm sure that nobody would like to repeat that experience. I mean, in the sense that nobody would like such a mishap to ever happen again. In Technocrat Talks, that is this channel, we earnestly wish to focus only on the engineering approach to view this incident, with a focus to throw up ideas to prevent recurrence of such mishaps going further. So we are not really analyzing the event, why it has happened. We are not investigating. We are not doing investigative journalism. We are simply putting technical facts of how such things can be prevented going further. Without much ado, let me introduce today's guest. Today, I am honored to have, and of course, eminent person in geology. He has done PhD in a very relevant topic for this talk, that is correlation of rock quality parameters and support system in Himalayan tunnels. Post superannuation, he has founded an organization called DDAG Pvt Limited. That organization works for training in engineering geology and provides consultancy for infrastructure projects like this one. He has been a CMD at MECL, which is a public sector undertaking under Ministry of Mines. He has served in NHPC as head of engineering geology and project engineering division, investigation division as executive director. He is also a member of panel of experts for NTPC, Tapovan Vishnugarh project, THDC, etc. He has been office bearer and member of several national and international professional bodies. He has also been a recipient of several iconic awards. Sir, welcome to the show. It's our pleasure, and we thank you earnestly for agreeing to talk to us on this subject, which is very, very hot topic of the day. And so, sir, the first question that I would like to ask is to describe your experience of similar kind of situation where you have been involved in such risky tunnel excavation operations, and what were those kind of some anecdotes or surprises that you faced during such kind of activities?
Thank you very much, Mr. Khare, for inviting me to speak on the recent Silkyara Tunnel tragedy on your platform, so that I can speak to your audience. To answer your question, my association with tunneling had been since inception. I am a geologist by training, and I joined NHPC as an executive trainee in 1980. At that time, my first posting was at Loktak project in Manipur, where a hydropower tunnel was under construction. It was a 6.5 kilometer long tunnel, 3.8 meter diameter. But the tunnel was going through geological formations which were very rich in methane gas. And therefore, this tunnel had notorious history of methane blast. And once a full team of Messrs. Patel Engineering Company got killed, and the project was stopped for about a couple of years.
That was in 70, sir?
In 70s.
In 1970, okay.
And
how many people were killed in that incident?
I'm told about 100 people were killed.
Oh. Bigger tragedy.
Yeah, bigger tragedy. Yeah. At that time, the project was stopped for a couple of years. And then when NHPC came into existence in 1977, this project was given to NHPC. And in 1980, as a trainee officer, I was posted there. So we have worked in that tunnel, which was very hazardous. Of course, after NHPC took over the charge of construction. With God's grace, none of these kind of incidences, methane blast, took place, but lot of care and safety arrangements were provided by NHPC, and with the help of experienced crew, we could complete the project, and the project is under operation since then. Likewise, I had worked on several other hydropower tunnels. To name a few, Salal hydropower project in Jammu Kashmir, then Chamera stage 1 in Himachal, Dhauli Ganga stage 1 hydropower project in Uttarakhand, and many more. So my job is of a geologist. We help the tunneling industry on two accounts. One, during the investigations. Investigations means that we have to plan techno-economically feasible route for a tunnel. And we should bring out the geological details of the area through which the tunnel is to be constructed, so that engineers can plan the layout. They should design the tunnel according to the geological details. And then the construction planning is also done according to the geology of the area. Because you can't construct any tunnel by any method in any part of the world. It all depends upon the geology of the area that you have to choose the tunneling method also. So first of all, what is a tunnel? Tunnel is an underground route or passage driven through the ground without disturbing the overlaying ground. Tunnels are constructed for railway, highway. For metros, lot of tunnels are being constructed. For hydropower projects, lots of tunnels are being constructed. And for sewage also, tunnels are required. And for water storage, carrying drinking water from big reservoirs to the cities, tunnels are constructed. History of tunnels is very long. In India, tunnels are, it is understood that tunnels were constructed even during the Mahabharata times. In Europe, Babylonians had constructed tunnels around 4,000 years ago. In India, the first record of tunnel comes from railway in Mumbai. But maximum tunneling work has been done by hydropower industry. Now, lot of tunneling is being done for railway and highway, and lot of tunnels have been constructed in Himalayas for railways and highways. So when you make a tunnel inside the hill, there are so many problems which we face. As I told you, methane blast was one. Likewise, many times the rock from the roof or from the walls, it falls, and we call it as cavity formation or chimney formation. Many a times the cavity is so huge that it gets daylighted into the sky through the hill. And there are so many other types of problems which we faced during construction of tunnels in NHPC. One big mishap took place in Parvati hydropower project, Parvati stage 2, which is in Himachal. This tunnel is now about to be completed. Here we were constructing this tunnel through a tunnel boring machine. And about 10 years ago, all of a sudden, we noticed that there was a profuse discharge of water through a probe hole. Because when you do excavation, so for safety reasons, we try to do some probe holes so that we know that what strata is going to be encountered during excavation by the tunnel boring machine. And through that hole, almost a big reservoir of water was connected, and uh, this tunnel was covered by flowing water, debris, and silty sand for more than a kilometer or so. The entire tunnel boring machine was buried under this deluge of water, which was mixed with a lot of sediments. Likewise, we have faced a problem in Dulhasti, TBM also, and TBM working had to be stopped there. Sometimes, after construction of tunnels, the supports which are provided for construction of tunnels, they get squeezed because of the so much of stress inside the mountain due to the pressures which are exerted on the supports. Normally, these supports are either steel ribs. These are I sections of steel, or it may be lattice girder, and many other types of supports are nowadays are in vogue. Technology has improved a lot. There are so many techniques of improving the ground strength by pre-grouting. So these the supports which are provided, they, due to squeezing, they start yielding, and if you have provided steel sections, they will squeeze, and the section will get reduced. So this also we have noticed in many sections of Teesta project, which is in Sikkim, and the project was completed timely, and it is in operation, successfully in operation. Although it has also suffered some problem due to the recent floods, in which Teesta 3, which belonged to a private company, or Teesta, along with the Teesta government, that got damaged. But NHPC projects have also suffered some problem, but the problem is repairable.
So this kind of collapse of tunnel can happen even after construction of tunnel, or it happens during only excavation phase, because that squeezing that you were talking of the structure, support structure, suppose it happens afterwards when the tunnel is in use. I mean, have you heard of such instances?
Yes. Very important question, Mr. Khare. You see, chances of collapse are more during construction, but it may happen even when the tunnel is commissioned, or it is under operation. In hydropower sector, there are examples where collapses have occurred even after commissioning. I will name a few for hydropower, because in a hydropower we have got one advantage, that these are constructed for carrying water. So even if something happens, there is no casualty, and whatever damage occurs, it can be repaired. But first of all, why I said that it has got more probability during construction? The reason is that during construction, you excavate the rock, it takes some time to support it, and in case rock is weak, it will have tendency to fall much before you can support it. So we normally, in our engineering geological terms, we call it stand-up time.
Yes.
I mean, the time for which rock can stand without support. and it depends not only on the geological characterization of the rock, but also the type and shape of the tunnel. If the tunnel is big, stand-up time will be less. And even after you provide support, initially you provide temporary supports. And temporary supports are finally covered by some kind of permanent support or lining. So once you provide lining before commissioning, so the chances of collapses reduce.
अभी आपने जो बताया कि ये tunnel supporting structure including concrete beams etc are introduced for support, and the other videos of tunnel which are in news recently are those Gaza tunnels which we see where we see those curved concrete beams and concrete slabs which are lining the tunnels. Now what is the time gap? Excavation होने के कितने बाद में ये structure जगह में आते हैं usually?
जी देखिए, टेम्पररी सपोर्ट तो साथ के साथ लगते हैं
जी, या
लगने चाहिए,
या
कभी कभी डिले होती है उसमें, मगर वो होनी नहीं चाहिए। डिले होती है उसमें 1 हफ्ता 10 दिन 1 महीने से ज्यादा नहीं होती।
जी जी,
टेम्पररी सपोर्ट। अच्छा, टेम्पररी सपोर्ट खुद भी टनल को मतलब स्टेबलाइज करने में सक्षम होते हैं
जी,
मगर जब तक परमानेंट सपोर्ट नहीं आ जाता तब तक उसमें थोड़ा बहुत चांस रहता है कि कुछ डिफॉर्मेशन हो जाए। ये जो एक आपने टनल बनाई पहाड़ में, उसका एक आपने डायमीटर बनाया जी। जैसे आपकी ये जो टनल है ये करीब 7.5 मीटर लंबे ऊंचाई में है जी, और 12.5 मीटर इसका स्पैन है जी, सेमी सर्कुलर टनल है ये। तो ये जो एक ज्योमेट्री बनी जी, वो पहाड़ के दबाव में, प्रेशर में ये थोड़ा सा क्लोजर आएगा इसमें जी। तो उसके लिए भी डिजाइन में प्रोविजन होती है और ये सपोर्ट इसीलिए लगाई जाती है कि उस क्लोजर को रेजिस्ट करें, और इसके लिए इंस्ट्रूमेंटेशन किया जाता है जी। और वो अगर वो इंस्ट्रूमेंटेशन एक किसी पर्टिकुलर रेट से ज्यादा डिफॉर्मेशन हो रहा है तो तब तक परमानेंट सपोर्ट नहीं लगाया जाएगा जब तक वो अपने फाइनल एक एक्सेप्टेड रेट पे उसका डिफॉर्मेशन अरेस्ट नहीं हो जाएगा। अगर डिफॉर्मेशन की वो गति बढ़ती रही जी, तो परमानेंट सपोर्ट को थोड़ा सा डिले किया जाता है। अच्छा, जो होना है वो हो जाए
पहले हो जाए। अच्छा अच्छा अच्छा।
आपने परमानेंट सपोर्ट क्या होता है? नॉर्मली कंक्रीट लाइनिंग होती है।
ओ यस,
या तो कंक्रीट लाइनिंग होती है या आजकल शॉर्टक्रीट भी करने लगे हैं।
तो सपोर्ट का जो सर थिकनेस है ये कांस्टेंट रहता है या इसको अडेप्टिवली चेंज करना पड़ता है डिपेंडिंग ऑन कंडीशन?
क्राइटेरियाज हैं जी, कई क्राइटेरियाज हैं। उसमें से एक डिपेंड्स अपॉन द रॉक टाइप,
यस, दूसरा
टनल का साइज,
यस,
तीसरा टनल किस पर्पस के लिए आप बना रहे हैं,
यस।
तो और विद इन ए one tunnel there may be several sections of the lining thickness।
करेक्ट।
कमजोर रॉक होगी, मोटी होगी।
yes।
हाइड्रोपावर टनल्स में ज्यादातर 300 mm की थिकनेस की ये कंक्रीट लाइनिंग होती है
जी जी,
जहां लाइनिंग होगी। आजकल बिना लाइनिंग के भी अब बन रहे हैं, वहां शॉर्टकट से काम चल रहा है, उसे मनी। और ये जो आपका सवाल था कि भाई टनल बाद में गिर सकती है, तो देखिए हाइड्रो पावर प्रोजेक्ट्स में तो गिरी है और रेक्टिफाई भी हुई जी। मतलब पानी चलते हुए पानी में, टनल तो नीचे है, किसी को पता नहीं है, और पता लगा कि आपके टरबाइन में से भी कभी कभी ऐसा हुआ है कि पत्थर निकलने शुरू हुए
जी जी,
तो पता लग गया कि भाई ये कुछ हो गया, टनल को बंद किया जाए और देखा जाए। फिर अंदर घुस के लोग इंस्पेक्ट करते हैं, तो एक बार हमने भी किया। तो फिर हम देखते हैं कहाँ जाके भाई डैमेजेस हुए, टनल कोलैप्स भी होती है उसमें, उसको रेक्टिफाई किया जाता है, जैसे मैंने लोकटक टनल का आपको बताया था, और भी कई टनल्स हैं। मगर ये जो आपकी टनल्स ट्रांसपोर्टेशन टनल्स हैं, चाहे वो रेलवे हो, मेट्रो हो
जी।
या हाईवे टनल्स हो, इनमें आप ये चांस नहीं ले सकते।
हाँ हाँ हाँ।
तो मेरे नॉलेज में कोई ऐसा वो है नहीं कि जिसमें कोई कोलैप्स हुआ हो,
अच्छा,
इंडिया में तो नहीं।
ओके।
हाँ, तो
सर, ये अनसपोर्टेड लेंथ जो है टनल का, सपोज आप फ्रेश एक्सकेवेशन कर रहे हैं, तो कितना तक लेंथ साधारण अनसपोर्टेड हो सकता है किसी भी एक्सकेवेशन में?
once again depends upon the rock. There
Yes.
are rocks which do not allow you to have stand up time of few minutes.
ओके,
तो अगर आप उसे सपोर्ट नहीं करेंगे तो वो गिर जाएगी।
गिर जाएगा। हाँ,
और डिपेंड्स अपॉन द साइज। अगर आपकी टनल का साइज ज्यादा है
यस,
तो आपको बहुत जल्दी सपोर्ट करना पड़ेगा।
ओके।
तो अगर अगर मान लीजिए टनल फॉर एग्जांपल बहुत बड़े डाया की है, जैसे यहाँ पे 12 मीटर डाया की टनल ये बना रहे थे, और अगर वीक रॉक आती है तो फिर उसको एक्सकेवेशन को भी छोटे छोटे टुकड़ों में बांट दिया जाता है। जी, वो इसको हेडिंग बेंचिंग में, मतलब ऊपर का हिस्सा पहले एक्सकेवेट कर दिया, उसे सपोर्ट कर दिया, फिर बाद में यहाँ पे भी यही किया जा रहा था। हेडिंग अलग थी, बेंचिंग अलग थी। और अदरवाइज
कई बार मैं ऐसा इमेजिन कर सकता हूँ कि सपोर्ट लगाने वाला शायद कॉन्ट्रैक्टर अलग होगा, एक्सकेवेशन करने वाला
ऐसा नहीं होता।
ऐसा नहीं होता। अच्छा, कोऑर्डिनेशन में हो जाता है, कोऑर्डिनेशन बराबर हो जाता है, कोऑर्डिनेशन दोनों पार्टी में हो जाता है।
देखिए टनल उस आदमी को दी जाएगी पूरी बनाने के लिए।
जी जी,
तो वही एक्सकेवेट करेगा, वही बनाएगा, और ईपीसी कॉन्ट्रैक्ट में तो डिजाइन भी वही करता है।
अच्छा अच्छा, ठीक। कोऑर्डिनेशन इज नेवर एन इशू। पूछने का कोऑर्डिनेशन प्रॉब्लम इज नॉट द इशू। यस,
नहीं, वो नहीं होती है। वो विद इन द कॉन्ट्रैक्टर्स टीम्स, अगर उसमें कोई दिक्कत हो तो उसको, उसके चेक्स एंड बैलेंसेस हैं उसमें। फिर डिपार्टमेंट का काम होता है कि वो उनको पकड़ता है, कहता है कि भाई डिले क्यों हो रही है। डिपार्टमेंट के भी होते हैं,
डिपार्टमेंट मैनेज करता ही होगा, दैट इज
करते ही है। और जब हमने नौकरी शुरू की तो खरे साहब उस वक्त तो डिपार्टमेंटल काम थे सारे।
जी,
अब हमने तो खुद खड़े होकर टनल बनवाई है।
जी,
अब तो ठेकेदार बनना के लोग काम करते हैं। उस वक्त तो हम एज ए शिफ्ट इंचार्ज खड़े होते थे।
जी,
जो लोकटक टनल का ही मैंने आपसे नाम लिया।
जी, जी,
तो और उसमें हमारे जो परमानेंट एम्प्लॉइज थे वही काम करते थे। ये तो मतलब कॉन्ट्रेक्चुअल सिस्टम तो पनपा है लेट 80s में आके। शुरुआत में जब एनएचपीसी ने 3 प्रोजेक्ट एक्वायर किए, लोकटक, सलाल और बेरासूल, इन तीनों में डिपार्टमेंटल वर्क्स थे।
जी, जी।
Now we should focus on the present problem.
Yes.
But before I go to Silkyara, I would like to explain in brief that how a tunneling project is initiated. So you will see in this picture, it is from Himalayan terrain. Normally, tunnels in Himalayas are constructed in similar topography and Himalayan rugged, inaccessible areas. You can see that the red line on this picture is alignment of a tunnel which will be constructed inside the tunnel. So whenever a tunneling project is started, a reconnaissance survey is initiated, and with help of available topographical maps, satellite imageries, you first of all decide that what could be the best route of the tunnel. But now here the problem is that all the possible routes of the tunnel are covered with thick foliage or overburden. So you really cannot estimate the type of rock and quality of rock without proper investigations. And doing investigation in Himalayas is a big challenge because Silkyara Tunnel is almost, located in similar terrain. So therefore, I am trying to explain the challenges which we face in Himalayas. Otherwise, we construct tunnels in other parts of India also, in Peninsular India also, in Deccan Traps, and nowadays tunnels are being constructed almost every part of India. But Himalayas have a very, very special set of problems as far as tunnels are concerned. Terrain is inaccessible, geology is complex, and you do not see any rock which is visible in this picture. So in geology, we call these as outcrops. So outcrops are very less. And because accessibility is poor, so we cannot take our big drilling rigs for drilling work in these areas. With these sets of problems, we have to estimate that which alignment will be better, and along the final alignment, what type of geological formations will be encountered when we construct the tunnel, and what sort of preparation we are required to do. So that's a challenge. So similar challenges were faced, or must have been faced by people who have conceived alignment of Silkyara Tunnel, and they have been constructing this tunnel. As far as Silkyara is concerned, this is a 4.5 kilometer long tunnel. It's a part of Chardham Mahamarg Pariyojana, which envisages construction of 900 kilometers of highway, and there are several tunnels wherever road construction is difficult or routes are circuitous. So for reducing the distance and stability, and wherever slopes are not stable along the roadside, tunnels are being constructed. And this Chardham has been conceived by Government of India to connect the 4 holy towns, Yamunotri, Gangotri, Kedarnath, and Badrinath, through the road network. A railway project is also under construction, which is known as Rishikesh Karnaprayag project, that is also being constructed. So this Silkyara was planned for connecting Yamunotri. And as I told you that this is a 4.5 kilometer long tunnel. It's a 2-lane bi-directional tunnel between Silkyara Bend and Barkot. These are the 2 ends of the tunnel, and in technical jargon, these entry points and exit points, they are known as portals. So I'll be using this term portal in my subsequent discussion. It will be a part of NH 134 in Uttarakhand. The project has been planned by MORTH, Ministry of Road, Transport and Highway, through NHIDCL, and Messrs. Navyuga Engineering Company. They are the contractors of this tunneling project. The design is, because this is a EPC mode project, so design is under the responsibility of EPC consultant. This 4.5 kilometer long tunnel was under construction from 2 ends, Silkyara end and Dandalgaon end, which is also known as Barkot end. So these are the 2 portals. In between, as of now, about 477 meters of excavation was remaining from Silkyara end, on 12th of November, a big collapse was noticed and workers got trapped. You will see in the next picture, wherein you will appreciate that there is a rock plug in between these two portals, which is 477 meters. And at about 205 meters, the collapse occurred. And these 41 workers got trapped. Initial report was of 40 people. And later on, we came to know that the exact figure is 41.
Sir, any prima facie reason of that collapse that we know, or it's yet to be investigated?
Yet to be investigated, but I will cover in my subsequent talk that what could be, what is the geological setup which can lead to this kind of occurrence.
Yes.
So this is the, you can say, the physical situation where these 41 people were trapped. On one side, there was unexcavated rock mass between the two portals. The length of this rock plug was 477 meters. And then on the other side, from where they entered in their shift during the previous night, this collapse occurred. And this collapse has occurred from chainage 205 to about 265. So it was a 60-meter wide mass of debris which came in the way, and these workers could not get out of it. And this all happened on 12th of November at 5:30 a.m. when all of us were, celebrating Diwali. This we came to know about this tragic event. This geometry of the tunnel is of a semicircle. It is about 12.4 meters at the base and 7.5 meters high. So this is a huge tunnel because this is a bidirectional tunnel. When this happened, so the first reaction of the construction company was to remove this pile of muck. But they soon noticed that as they started removing the muck, you can see in this picture that two excavators are working. And the more they removed, the more it came. And it is but natural that because this mass is coming from top of the crown of the tunnel. So, and you do not know that how much material is there, loose material is there inside the cavity. So as you will remove the toe of the material, so it will come. It is just like a heap of sand. If you disturb the toe of the heap, the heap, then sand will slide down. So soon it was realized that this will not work. And therefore, the plan A, rescue plan A was started. You can call it plan A initially. It was drilling of a horizontal rescue hole by a auger machine from the Silkyara end, because best and safest alternative at that point of time. So a auger machine which was locally available with Uttarakhand Irrigation Department was brought, and pipes were also brought. You can see it in the picture, pipes are loaded on a truck at the tunnel site. And initially it was thought that they will drive 900 diameter pipes. After the auger does its job, and simultaneously pipes will be pushed inside the hole by hydraulic jacking. But soon after they could go only a couple of meters, the auger machine broke down, and this rescue operation got suspended. So there was a panic at that time, but soon a decision was taken to bring new American auger drills. I think it was on 15th of November. And with this machine, this was installed, soon after, without losing time. And this all I'm speaking out of the knowledge I have acquired through reports in the media and some technical information, which I got through my friends which were working at site. I had not been to site, so this is a disclaimer from my side. But after going for about 24 meters, the pipe got stuck. And then there was a real panic. And then government ordered all agencies who have any experience in tunneling or rescue or mining that they should come, and several plans were discussed with them. Initially, we had NDRF there, SDRF was there, NHIDCL was there, who is the owner of the project. Then Geological Survey of India also came. ONGC people came. SJVN, Satluj Jal Vidyut Nigam, they came. RVNL, who are doing very successful tunneling in the Rishikesh Karnaprayag line, their officers also came to site. RITES was there. In fact, all railway PSUs were instructed to reach at site. Indian Army people came. Coal India came, along with Simfer from Dhanbad. And many private companies were requisitioned to take part in the rescue operation. And I have a friend of mine, Dr. Sanjay Rana. He, on his own initiative, he is a very good geophysicist. He sent his team from his company. The name of the company is Parson Overseas. So Sanjay and his team, they visited the site and they provided all geophysical investigation backup to the rescue team, so that they know that what is there in advance, what is the size of the cavity, how they can plan locations of various alternatives. So at that time, Dr. Arnold Dix also flew to India. Dr. Dix is president of ITA, International Tunneling Association, and a renowned personality in tunneling industry. And he stayed all through during these days and really helped a lot to the rescue teams. Although it was a teamwork, all the agencies have contributed significantly, but I think there are few people who have to take lead. So he was one of them. So now the plan was to continue on the plan A, but now start other alternative plans also. Because the second time this auger machines broke down, and that had really created a lot of panic. Then at that stage, it was considered that as a plan B, a vertical hole will be driven from the top of the mountain, and through survey and geophysical estimation, its locations were uh, decided. And at the pre-decided location, after uh, investigations, first of all, a small diameter hole was done, and then it was planned to have a big diameter hole. This responsibility was given to SJVN. But simultaneously, uh, other other rescue operation teams, they commissioned the auger again, the American auger again, and American auger did a very fast progress, and we were almost at the at the verge of a breakthrough. There was a lot of hope at that time to that this operation will be successful. But all of a sudden, at around 55 meter, if I remember correctly, no, 53 meters, the auger broke down again. And this time, the auger machine itself got totally consumed inside the hole. Its spiral blades got damaged. They were badly stuck, and the pipe was choked. Machine completely broke down, and it was beyond repair. So that was the second phase of a difficult time, but the rescue teams kept their morale high and got over all these difficulties. They first of all removed the components of auger machines which were there inside the pipe. This plasma cutters were brought from Hyderabad, and these people work inside these very small diameter pipes, because initially they started with 900 then they reduced it to 800, and then finally it was reduced to 700 Telescopically, these pipes were going inside, and in these pipes, they performed this gas cutting with a lot of skill and courage, and pipes were cleared. But in the meanwhile, these other options were also people who were working on other options, particularly the vertical drilling. That was continued. And the day before the actual rescue on 28th of November, this vertical drilling was completed up to around 40 meters. So about half of the drilling depth was completed. But when on 27th, it was we were very close to this breakthrough through the rat miners. So everybody was hoping that now this is the final assault on this problem, and we will have a breakthrough anytime. So then this vertical drilling was stopped, and other options, I'm not going into details of other options, because these were the two options on which serious work was done. I would try to explain the situation with help of this sketch. You see the hill topography, and you can also see the tunnel, which is shown by double line. And in between this tunnel, you will see a red color heap. This is the 60-meter wide collapse, heap of muck in form of a collapsed zone. And this collapse consists of the rock debris, the broken parts of the supports, lattice girder, steel ribs, rock bolts, and other types of support elements which are mixed in the muck, and there were two. It is given to understand that two or three equipments were also buried in the muck. So, and these are the obstacles which came into the way when the auger machine got damaged, because auger machine can handle the rocks. It can cut through the rocks. It can cut through various types of natural debris, but it cannot cut the steel elements, or even if it is mass concrete, it will have difficulty. So therefore, the blades of the auger got damaged. Geologically, you will see that there is a contact between two types of rock formation. One is the amphibolites or metavolcanics, and the other type of rock below the tunnel is sandstone, siltstone, slates, shale. So these are the group of rocks. Because rocks are not uniform, so these are the amalgamation or combination of various rock types. So these are the two rock types, and there's a dotted contact which is shown here. This contact is said to be sheared, that there was a very weak zone along the contact. Maybe that this was the root cause of the collapses, and we are told that during construction in 2019, when this tunnel was under construction, at that time also several cavities have taken place, and it was difficult to negotiate this part of the tunnel during initial construction.
You mean, sir, that layers may have become loose with respect to each other, the addition?
Yes, if they are not supported properly,
Yeah.
they will further become loose.
Yes.
They will exert load on the supports.
Mm-hmm.
Here, we are told that the support was by rock bolts, shotcretes, and lattice girders. Okay. Lattice girder are modern types of supports, which are placed to replace the conventional steel ribs. Okay. It is a part of NATM method of construction. So it is, there is nothing wrong with this. It is being done in several Himalayan tunnels, but it depends that what was the whether the support was enough or not, and if enough support was provided, what was the quality control. So it is all a matter of study. We really do not know that what could be the reason, but geologically it is said to be a weak zone. Okay. In which this tunnel was placed in this section. Sir, some time back you have said a word metavolcanic. Does it indicate proximity to volcanic activity in the zone? This is all ancient. This is a result of some volcanic activity, but in historical time. Achha, not now. There is no recent volcanic activity. There's no sign of any. It's not a volcanic activity prone zone. So no, not at all. Not at all. Yeah. So, as I said that this is the geological setting of this area, and there was a history of collapses during construction. Now it is understood that because this tunnel is almost under the final phase of the construction, so it was being lined from both the ends, from both the portals. The Silkyara end is shown here, but the other end, Barcoat end, is not shown. So you will see from Silkyara end, a part of the tunnel for about 80 meters or so. You will see that in this sketch, concrete lined tunnel is written. So till 80 meters, the final lining was also placed. And now this rectification of the supports further beyond this 80 meters were in operation, because before lining, you will have to bring the section to the required design section if there is some kind of squeezing or there's some deformation or damage of the primary support. So it was under reprofiling. And it is told that during the reprofiling, this cavity has taken place. So this is about the geological setting. And the option A or the plan A was the drilling a hole using auger through this muck. This is plan A, and plan B is also shown here, where you see a drill machine on the top of the mountain, and a drill hole of 86 meter could have reached the tunnel grade. So that was the plan B. Suppose in case plan A would not have succeeded, because there were two occasions when the machine broke down. So then simultaneously plan B was also in action, and it has already done about 40 meters, as I have said before. So this is the whole explanation of geology and the rescue operation plan. So I will come back to plan one, plan A, wherein I have told that the auger machine was pressed into service, and at 53 meter it broke down again. Then the broken part of auger machine were brought out after gas cutting or plasma cutting. And then at that time, because now auger was the last option, and there were too many obstacles which auger had seen, so it was decided at that time that let it be done finally, manually. And the remaining portion was hardly less than 15 meters or so. And at that juncture, the rat miners were roped in as the last mile saviors, and they came out as true heroes who helped to negotiate the final 15 meters stretch out of the total 65 meter through the rubble. And they did it very fast. They took hardly 27 hours to negotiate the balance 15 meters, and they brought all the 41 trapped people successfully.
So what do we call rat miners? I mean, what is that term? I'm sure people don't know. Many people will not know. So could you elaborate?
Yeah. Maybe. Actually, this is a term which is very common in the coal mining industry.
Okay.
And to tell you the truth, this is a this is not a legally accepted mining
Colloquial term. Yeah. Yeah.
Yeah, I mean, it was done before, but slowly, because it is very risky for the people who do it, and it is illegal. So it is not encouraged. Maybe unofficially or illegally, some people would be doing. So this term had come from the coal industry, where people they dig very small diameter holes inside the coal seams and take the coal out and then sell it illegally in the market.
Okay.
But this technique came to the rescue. But I really do not know that whether the team who was pressed into the service, they had no connection, perhaps, I'm imagining, with the coal mining industry, because these people belong to areas near NCR. There is a place near Greater Noida, which is known as Khajuri Khas. So 6 or 7 miners from there. One Mr. Qureshi, who was the main architect of or the main person who did most of excavation, because there was a team of 12 people, and they were placed into pressed into service through a private agency in Delhi. Unfortunately, I don't remember their name, but they have done a wonderful job. And this rescue operation will be remembered in history as a triumph of grit, determination, and the teamwork of the workers and the planners and experienced people who really rescued these 41 people. Otherwise, it was a really very, very difficult task. And I really take this opportunity to thank all of them who had contributed to.
Indeed, they have teamed up and raised to the occasion.
They raised to the occasion. And this is an example that if all of us, I'm speaking in Indian context, if we really work as a team, we can do wonders.
Sure.
I mean, as we can sense from the pictures which we saw on social media and on internet, newspapers, news bulletins. I mean, people have worked across the organization lines. There was no division. You can't differentiate that who belongs to which department. All of them work together for safety of these 41 tapped workers. And that gives a lot of confidence to the people who are working, because nowadays there are hundreds of kilometers of tunneling is underway. Lot of tunnels is being constructed. Maybe around more than 20-25 tunnels are under construction in Himalayas alone. So that gives confidence to the people who are working inside the tunnels.
Oh yes.
I also go, even at this age, I go to several tunnels wherever I'm invited, or I provide consultancy. So I also remain inside these tunnels, and God forbid any of us could be in that situation. It was because early in the morning at 5:30 that this incident happened. Otherwise, if the same thing would have happened during the day, there would have been hundreds of people like me, geologists, engineers, contractors, support services providers. Many of them would have got trapped in this. So now we have confidence that if this happens anywhere, first of all, it should not happen. People rise to occasion, but we have to prevent the occasion from coming as far as possible. There are ways and means. In some other occasion, we can speak, because now already the video is long. So on some other occasion, we can discuss what are the lessons learned. How can we stop these incidents? But as I said, if God forbid, if anything happens with anybody, now there's a courage in the working crews, working teams who are working. It is a 24-hour operation. Work is done in all the times, 3 shifts in a day. So people who are working there in the night shifts, they also have courage, that they have confidence in the government and owners of the projects, that they will leave no stone unturned, and we will be rescued. We will be given all sorts of help and supports. So with this, thank you very much, Mr. Khare.
Thank you, sir,
for inviting me again. And we will speak more about.
We'll continue sometime next session, maybe. Thank you very much. Thank you. Thanks for the nice interview. It has been an enlightening session. I'm sure audience is going to like it. Thank you. Namaskar.
Thank you. God bless you all.